is a storage format and protocol so that you can stream this data also from remote storage. For example, from distributed storage or cloud systems. Also, Zarr is chunked, which means you have your large array typically and partition it into smaller subparts and store these chunks as individual files or keys in your object storage in the cloud. This allows you to have parallel access. So typically, if you have really large data sets, gigabytes to petabytes, then you don't want to process it all at once, but you parallelize across compute nodes, and they can read and write parallelized across those arrays, because everything is stored, chunked, so you don't, if you partition your work also according to those chunks, everything works out nicely in parallel. And also, those chunks can be compressed. We have pluggable compressions. This means it's efficient also for rather sparse data or data where you don't have lots of variation. And this means it's just much faster to transfer the data. How does it look like if I want to read or write something? So let's say I have an array here of shape 14 times 14. And I specify a chunk size of 7 times 7. This gives me 2 times 2 chunks. And now I want to write in one part of this array. And let's say it's in this chunk 0.1. Then I set the new data in this chunk, compress the whole chunk, and write it down basically as a byte stream to your underlying system. And this can be in the cloud, AWS, Google Compute, Azure, on your file system. This also could be in memory, but this is a less typical use case, I'd say. On the other way around, if you just want to read, you find out which chunks are affected and get those from the underlying system, decompress them, and reconstruct back the array. In Python land, what you work with in the hand basically is a NumPy array, but you can just specify subparts of your large Zarr array and interact efficiently with this larger array and get NumPy arrays from your system and write it back to it. So this just showcases, I mean, if you have a really large array, the wasted space, if you would want to fetch it, is much larger. But yeah, depending on your chunk size, you can just have very efficient requests and just access the data that is actually needed for your task, or parallelize for each chunk or a bunch of chunks very nicely. Zarr is not only a Python implementation where it originally started, but also has lots of libraries around it. I mean, of course, it uses NumPy. It also can give you back other array structures in the meantime, not only NumPy arrays, but it could also be that your array is still on the GPU. It works with Dask. Dask has support for Zarr directly and can parallelize across Zarr chunks nicely, and it uses it's usable with xarray. Xarray is nice if you want to specify what the different dimensions of your data mean, for example, for physical data, and this also supports Zarr under the hood. Besides Python, there are different implementations. So there's the main Python implementation. There are multiple C and C++ implementations, a Rust implementation, also an R implementation. Always when I see the logo, I remember it. Julia, JavaScript, and a Java implementation as well. So what are the typical use cases? If you have large arrays, typically. If your data all fits nicely into memory, you don't have to necessarily have efficient streaming back and forth. But once you want to parallelize, once your data doesn't fit into memory all at once, Zarr is a very nice use case. So it's used in bioimaging for microscopy images. This can be two-dimensional, three-dimensional data. You have typically multiple channels or even time axis. Geospatial data, so satellite images, also often with a time axis as well. And you can easily, in both domains, have data sets where one data set is in the petabyte range. And I mean general data science, genomics, physics, chemistry, there are so many use cases. Information sciences. Yeah. If you want to have a look for yourself how it looks like in Python, just on the technical level, there are some code and data examples. I won't go into detail because this talk actually isn't about the implementation or the API specifically, but more about the ecosystem. Yeah, there you can also see different use cases, different areas where it might be used. This is just a notebook. So we started with the implementation, but Zarr is much more than the Python implementation where it started now. There's a whole ecosystem around it, and I want to show you a bit of the journey, how this grew, and what are we doing now for the ecosystem. So Zarr started in 2015 with a first commit on a Python repository. Alistair Miles initiated the project and presented it at SciPy in 2019. That was Zarr version 2, which is at the moment the main version. And back then already work on a next major version started. Then there was a CZI, so Chan Zuckerberg Initiative grant for Zarr, and Zarr was backed by the NUM Focus organization, which basically acts as a body that can organize finances and stuff like this. And there was a steering council initiated where the core maintainers basically came together, and it was clear who the core maintainers of the project are. In 2021, there was a new homepage, a new logo, just since it grew, and we had multiple implementations. And by we, I wasn't involved yet in this project. So this needed some representation beyond just having a single GitHub repo as an entry point. Last year, there was another grant, which also helped to fund the community manager, Sankit Verma, who is basically organizing all of this what is around Zarr in the implementation and helps just to foster the community, and also initiated an enhancement process similar to PEPs or NEPs or SCEPs or all the other ones. There's also a Zarr enhancement process now, Zarr enhancement proposal process. And we actually tried it out now this year for the first time. The Zarr version 3 is actually now accepted officially, and implementations are currently on the way. And this is also where I got into the process, basically. I helped to finish this Zarr version 3. And yeah, just want to showcase a bit what's all around Zarr now. And I mean, it was presented again also at SciPy. I think the talk is already online, and now here. So what did we change from back then? I mean, Zarr grew from one Python implementation to different implementations across languages, but that also meant that you had different features in different languages. Some features were supported in that implementation, some not in the other. Then they started a specification for Zarr v2, but also what do you put in the specification? And yeah, it's just really hard to do a specification after you already have the implementation in hand, and not only one, but multiple. So for Zarr v3, we rather turned this around and start with the specification. We accompanied with an implementation just to demonstrate it and make sure that it's also feasible. But we have Zarr v3 from the ground up with a specification now, and everybody is cooperating across different languages on that specification. And that means that many things that were, for example, very clear for Python developers, but maybe not for other implementations were questioned. And things like, how do we handle zero-based and one-based languages, like Julia, for example, is one-based. How do we handle differences there? What's technical problems that we have in the specification or in the implementations before for C-based languages that they cannot easily resolve? What do we need to change in the specification? And discuss that before implementing it all. And that's what we did with v3. And what does it look like? We have a specification on a homepage and just a GitHub repository backing that. So the process was to propose a specification by first Alistair Miles, and then there was a large review process, which actually took multiple years. And now Jeremy Martin-Shepard and me finished up this work and had now something that was voted on in the beginning of the year. And now V3, basically, the specification is out there, and the first implementations are ready. And this is the thing that will be supported in the long run. So everything then also is done on the specification level, still in GitHub. I mean, the most people contributing to it are developers, so are very familiar with it. We do reviews there just as with code, but on the spec level. So how does this look like? The Zarr enhancement proposal process describes how this whole thing looks like. Some authors propose a Zarr enhancement proposal. This is always then on a spec level. We always have to have a spec, because just an implementation will make it hard for somebody not familiar with that language, or if it's very complicated, to adapt that to another implementation. But also it should come with some code that showcases that it's technically feasible, how it actually looks like in practice, and so on. Then there's iterations with a community over this. So this is publicly announced. We have a draft, and then there's some back and forth. The specification might be changed. Things might be challenged, different alternative solutions might come up. So this whole thing depends on how long it takes. Usually it shouldn't take as long as a new major version in our case, but rather some months. And then in the end, when basically this whole process converges to some point where we see, okay, we've heard all arguments and try to consolidate into the proposal, the implementation council and the steering councils vote on it. And they basically take the broader community into account. And then things get implemented, of course. So how to know what to do if you want to hand in a Zarr proposal? In our case, there's the step 0, which describes the whole process and basically tells everyone how to hand in a proposal. And there's a template. Basically, you can fill it out and go with that for your proposal. On a meta level, there's an open governance scheme. So there's a markdown file in a GitHub repository, of course, that describes what the whole process is, how you can get involved, how the councils are set up, etc. By the way, there's currently also an PR open still about the SEP process and how to incorporate that in the whole governance thing. So what are the lessons learned in the process? And this first time, we did the first SEP now for a new major version, and that was quite a long thing. So what did we learn in that time? Communication is most important. You have to be open for feedback. If you put out a SEP, people will give you feedback. There might be alternatives, so you should be open for that, of course. You should gather your feedback as early as possible. It's always not nice if you sink in huge amounts of time into something and then you need to change things massively, but could have gotten the feedback much earlier. Try to keep the feedback loops very short, so if you get some agreement on something, try to actually do it directly and change things accordingly in time. And, very important, keep discussions on topic. That wasn't necessarily the case. Once you have a review, and in our case it was a quite long review, we had multiple, over 100 issues. You need to see where the communication is happening for a topic and try to redirect people to the right things, close topics somewhere, and yeah, redirect. And, of course, in-person meetings are also great, or remote meetings. They have the highest throughput and are great for technical coordination, like finishing up the last touches, but not necessarily for consensus, where you want to reach most people and just get the best feedback you can. So again, communication is key. Spec and code must be editable easily. Large projects, of course, need project management. And Zarr, at this point, if you have a large thing like a new major version, that is a large project. Just as an example, this was on an intermediate review PR. So I had the comment section, just unrolled everything, and on my display it was over 20 meters. So try to organize that. It's quite a bit. Yeah. it's great if you have a transparent process, because then also people can give feedback on that process and you can change it accordingly, and it's not just something given to you. And yeah, just make everything editable, put it into GitHub, also the meta stuff. It's part of things that can change and should be reviewed, and changes should just be PRs. If you're interacting with developers, it's basically the way we do things. So this is basically the whole Zarr ecosystem around it, and it's way beyond just the implementation. It consists of many people contributing to it, and in the meantime also processes. Yeah, and this is basically what we learned along the way. Happy to take your questions. Thank you.
So thank you so much, Jonathan, for your talk. We have time for 1 or 2 questions.
Jonathan, thank you. About communication, which is important. I mean, you listed multiple things, but how to ensure that it's actually effective communication? Do you have any tricks to share?
So, yeah, I think coming back to people directly, so in time, and being able to iterate within short time frames. And if you have a community spread around the world, I don't mean minutes, but rather within a few days, that helps. Because if a topic is started at one point, you have a discussion going, and then just it stalls, that's very hard to resume from there and basically get people back into the state of mind when they were in the discussion. And also, if you have feedback on something, to incorporate that directly is super useful. That's, for me personally, the 2 main takeaways. But yeah, so for effective things, if it's really not broader discussions and basically where you want to gather most opinions, trying to have direct communication in meetings is great. So by the time now, we do have office hours, there are community calls, but there are also SAP meetings where all current authors of SAPs are invited, and also people interested in contributing, and we just might discuss some things, clarify misunderstandings, get some technical things going, like, okay, you said I would approve this, but you didn't yet. Like those things, this is great there. Yeah. And by now, we also have working groups just for technical things that we push forward. Thank you.
All right. Actually, we don't have time for more questions, but you can talk with Jonathan later on. Thank you so much.
Thank you. See you around.